Hey guys, so today we are going to discuss about the question called as number of enclaves. So this is a medium question. This is a Leetcode medium question, which is a basic, like a graph question or a DFS question. So let's start reading the question. So you are given an M into N binary matrix called as grid, where 0 represents a C cell and 1 represents a LAN cell. So what they're trying to say is they'll be giving you a matrix or a grid which contains zeros and ones, where one represents a LAN cell and 0 represents a water cell. So let's continue. So a move consists of walking from one LAN cell to another adjacent 4 directionally LAN cell, or walking off the boundary of the grid. So what they're trying to say is you can move only from a LAN cell to another LAN cell, or a LAN cell to outside the boundary of the grid. So for example, let's say here, so this is a 1, right? So from this cell you can move only to the adjacent 1 cell, but you can't move from this 1 cell to the adjacent 0 cell. Or else you can move from this one cell to the boundary, outside the boundary, but not to the top 0 or bottom 0 or right side 0. That's what they meant. So you have to return the number of LAN cells in this grid for which we cannot walk off the boundary of the grid in any number of moves. Yeah, this is a bit confusing. So let's take with an example. So let's assume we have this grid. So this contains zeros and ones, right? So first thing is, what is a LAN cell? 1 is a LAN cell and 0 is a water cell, right? How can you make sure you cannot move outside the boundary of this grid? Let's assume we have this ones, right? We have these ones. So this is a component, right? This is a strongly connected component and this is a strongly connected component. So from this one, can you move outside the boundary of the grid? No, right? Because you can move to this one, you can move to this one. From this one, I'm saying from this one you can move to this adjacent one. From this one you can move to this adjacent one. From this one you cannot go to anywhere, because this is surrounded by 0, this is surrounded by 0, this is surrounded by 0. Even from here, if you start from here, the same case. If you start from here, the same case. So but if you try to start from here, you can go top, which is surrounded by 0. You can go to the right, which is surrounded by 0. You can go to the bottom, which is surrounded by 0. But if you go to the left, which is not surrounded by any 0, but it is an edge, it is a boundary of the grid. So that actually means this one, if you start from this one, there is a chance where you can go outside the boundary of the grid. So that's the reason why this you cannot count as an answer. So let's get a better example. So let's take this example. So let's consider we're having a grid which contains zeros, which represents water cell, and this which contains ones, which represents LAN cell. So how can we decide a particular LAN cell can be removed, or particular LAN cell is connected to a boundary of the grid? So this is a component, right? So this thing is a component. Like this is a component. So this is, let's draw it properly. So these entire 3 ones are connected to each other, right? So a component is nothing but group of ones which are connected to each other. So if they are connected to each other, then actually means that's a component. So if any of the ones in this component is connected to a boundary of the grid, that actually means we can move from any of the one in that component to the boundary. For example, let's say this one is connected to a boundary, right? So this one is connected to boundary at this place. That actually means this entire thing is a component, right? So if you pick any one of the one in this component, we can go to the boundary. For example, let's say if I pick this one, I can go from here. So even this is connected to a boundary, so I can go out of the grid. Even if I go from to left and go to the top, even this reaches us to outside the boundary of the grid. So that actually means if anyone in the component is connected to a boundary, that actually means the entire component can be neglected. So all we need to bother about is a component which is not connected to any boundary, which actually means a component which is surrounded by all zeros. For example, let's say this is a 1, right? This is a component. How am I saying this is a component? Because this entire thing is a single component. This one is not connected to this one, because the two ones are only connected only if they are adjacent to each other in 4 directions, which is up, down, left and right. So this one is not connected to any other ones in any directions, right? So that's the reason why this is a single one, which is a component. So now this component is surrounded by only zeros, right? But not any of the boundary of the grid. So that's the reason why this can be considered as in the solution, because this, if we start from this one, we cannot go to the boundary of the grid, because this entire thing is surrounded by zeros. So that's how, like, you get to know whether a particular cell can be reachable to the boundary of the grid or not. So let's start, like, how do we get rid of these enclaves, and like technically how do we solve this? So let's take the same example again. Coming back to the concept, like the main thing which we are focusing on here is we don't want any ones to reach to the boundary of the grid, right? So what can we do is, we can first start from the boundaries. We can traverse to the boundaries itself, and we can find if there is any one connected to the boundary. These are the boundaries, right? So let's say we are traversing the first row. So I'll be seeing whether this is a one or not. This is not a one, right? I'll be moving towards right. So again, whether I'll see this is a one or not. This is a one, right? So now what I can do is, I can perform DFS from this one only if the adjacent one is one, right? So if I perform DFS from this one, and if I change every one to 0, that actually means I can get rid of the ones which are connected to boundary, right? So if I change this to 1, so this one is connected to this one, right? I'll be changing it to 0. So now this is a 0 and this is a 0, right? So there are no more ones which are connected to each other, right? So now I'll be moving forward again. This is not one. I'll be moving forward. This is not one. Again, similarly, I'll be seeing the remaining boundaries as well, if there are any ones or not. So in this case, there are no ones, right? So that actually means we are done with removing the ones which are connected to boundaries. So now what I can do is simply traverse the entire matrix and count the number of ones. So in this case, the number of ones are only 1, right? So the answer for this case would be 1. So this is the pretty much approach which you gotta do. So basically, we can perform BFS or DFS for this when we are trying to remove ones and replacing them with zeros, but I prefer DFS in this situation sometimes. So we can perform DFS or BFS. So now let's get to the code. So now we are having a method called as num enclaves, which contains parameters, a matrix. So this is a grid which contains zeros and ones, where 1 represents the land and 0 represents water. So let's stick to our approach. So what we do first, so we first try to traverse to the boundaries and try to find if there are any ones or not. If there are any ones in the boundaries, we perform DFS from there and remove all the ones or replace all the ones with zeros. So let's start with that. So initially what I'll be doing is, I'll be using two variables which is called as m and n, just to store the length of the grid, the number of rows and number of columns. So this m would be grid dot length, this n would be grid of 0 dot length. So now I'll be starting with the left column or the left boundary. So let's say this is the left boundary, boundary, and this is the top boundary, this is the right boundary, and this is the bottom boundary. So let's start. We can start with any boundary, but let's start with the left. So this would be the left. So for int I is equal 0, I is less than m, I plus plus. So now if grid of I comma 0 is equal to 1, then perform DFS from I comma 0. I will be passing the grid as well. So what we are trying to do in this for loop is, we are traversing the left boundary. So basically, if you traverse the left boundary, the column will be the same, which is 0, but the row changes, right? So that's the reason why I'll be using a loop which traverses from 0 to m less than m, which represents from 0 to the number of rows minus 1, and I'll be assigning this I to the row, and 0 will be always this column will be the same, which is 0. So I'll be performing DFS if I find any 1. So similarly, I'll be traversing the right side column, right side boundary. So let's name it as right. So this would be for int I is equal to 0, I is less than m, I plus plus. So if grid of I comma n minus 1 is equal to 1, then perform DFS from I comma n minus 1 comma grid. So Even here the same case, it's the same case. The column will be the same, which would be the last column n minus 1, but the row changes because we are traversing from top to bottom, right? So that's why we are increasing the row. So it will be 0 to m minus 1. So in the right boundary, which is this right boundary, if we find any one, we perform DFS from there and we replace every one with 0. Similarly from the for the top, let's take the top. So in here, for int I is equal to 0, I is less than n, I plus plus. Here we use n instead of m, and I'll tell you why. So grid of 0 comma I is equal to 1, then perform DFS from 0 comma I in grid. So here the row will be the same, which will be the top row, which is 0th row, but the column changes, right? Because we are traversing from left to right. This is the top row. So the row will be the same with the 0th row, but the column changes 0 1 2 3. So that's why we are using the 0th row every time, and for the column we are using the I value. Similarly for the bottom, so this would be the bottom. So for int I is equal to 0, and I is less than n, I plus plus. So if grid of m minus 1 comma I is equal to 1, then DFS of m minus 1 comma I comma grid. So this is for the bottom row. So the row will be same, which is m minus 1, the last row, and the column changes, which is 0 1 2 3. So if you perform, I'll be performing DFS for the boundaries at the beginning. So now what this DFS does, so we'll be starting the DFS method. So let's take this is a private in DFS or something. So what we're trying to do is we are trying to remove the number of, you say, let's say the ones, the ones to zeros. So let's take this is a void method, DFS int x comma y, and this would take the parameters as grid. So now as we are passing the starting cell, we'll start from the starting cell itself. So grid of x comma y is going to be 0, and what I'll be doing is I'll be traversing to the adjacent ones and change those to 0 as well. So this is the new cell, dx of I plus x, and I'll tell you what this dx is, dy of I plus y. So what I'll be doing is I'll be using an array, and this array will help us to traverse through adjacent cells. I'll be telling you how this works. So this would be a y array, 1 minus 1 0 0. So combination of 1x and 1y would be one direction. For example, let's say 0 and 1. So if I use dx of 0 and dy of 0, that actually means I am moving towards the right, because we are adding 1 here. We are not adding anything to row. Similarly for the other case as well. So now first I have to see if the new cell which we have found is valid or not. If valid of 0 comma b, which actually means we are not exceeding the boundaries, and as well that has to be a 1, right? So if it is valid, then we have to move forward, which would be DFS of u comma v comma grid, right? So let's implement the valid method. So this would basically be a boolean method, so which takes parameters of the x and y coordinates, or I and j, let's say for this case, and we'll be passing the grid as well, so that we can see whether the cell contains 1 or not. So the I should be greater than 0 equal to 0, and j should be greater than equal to 0, and I should be less than m, and j should be less than n, and grid of I comma j should be 1. So if all these cases satisfies, then only it's a valid cell. So if this is a valid cell, we'll go to that cell by performing DFS, and again we come to this position and we'll be replacing 1 with zeros. So this is how we replace ones with zeros. So now when we are done with all the boundaries, so now what we can do is I can traverse to the entire matrix, which would be like this: two nested for loops for int j is equal to 0, j is less than j plus plus, So now all we have to do is we have to count the number of ones, so that would be our solution, right? So what I can do is I can create a variable called as answer. So what I can do is answer plus um, grid of I comma j, because adding ones, the number of ones is nothing but adding the entire ones in the matrix, right? So it will give us the number of ones. So we just return the answer at the end. So this is pretty much the solution. So if you didn't get this for loop, let me try to explain again. So what we're trying to do is, after replacing all the ones with zeros which are connected to boundaries, the remaining ones would be the enclaves only, right? So which are not connected to boundaries. So if we sum up the number of ones, that actually means we have found the number of enclaves itself. So that's what I was doing here, adding ones, that's it. If you might get a doubt, as we are trying to sum up the entire matrix, how are we getting the number of ones? Because summing up zeros is nothing but nothing, right? So if at all it is one, then only our answer increases. So that's how we are getting the answer, and we are trying to return the answer at the end. So I think this is, yeah, this is a pretty much solution for this. Let's try to run this. Let's hope there are no compilation errors or something. Yeah, this worked. Let's try to use some other test cases as well. Yeah, let's try to submit this. Yeah, it got succeeded. So this is how you find the number of enclaves. So this is not like this, there are some similar questions as well, like some for example, like number of islands or number of provisions like that in Leetcode. So you can practice those questions as well. So this would be an easy solution. Like there might be some other optimal solutions as well. So if you find any optimal solutions than these, you can comment down below. So please make sure you like and subscribe. Thank you.